All right. Hello, everybody. Welcome to the next PyCon talk. This is Hynek, one of the C Python core developers, and he's going to be talking today about application deployment. So everybody give a warm welcome for Hynek.
Wow. I'm quite honored that so many of you chose to spend their food coma with me. And since I foolishly chose a very broad topic and we have a lot of ground to cover, I'll just ignore people still coming in and start immediately. So, you're here because you realize that Borat is right. Programming is fun, it really is, but deploying the results is agonizing pain, right? So, in my experience, most of this pain comes from a lack of orientation, and I'm here to take some of the pain from you away. Good afternoon, I'm Hynek in real life, on Twitter, and all over the interwebs. I do some open source stuff, as already mentioned. To finance my glamorous open source lifestyle, I work for a tiny ISP in Germany you've probably never heard of, called Varemedia. We sell web hosting, mail services, domains, all the boring stuff. So, enough about me. What's on the agenda? I have to warn you ahead, it's going to be a whirlwind, because I have only 40 minutes to share with you, and all I will be able to give you is an overview. But I really hope to be able to replace that lingering anxiety inside of you through an informed annoyance. So, I really just want to push you in the right directions and hope it will help you somewhat. It's also going to be a whirlwind in the sense it will be really fast-paced. So in order to pull it off, I've set up a page which contains all the links I will be mentioning, all the projects, all the approaches, all the blog posts, whatever. This is the only link you will ever need. It's 7 characters. I just assume my babbling was long enough, so you have written it down. So let's carry on. It's also going to be an opinionated talk. I'm pretty sure that just as many nodding heads there will be turning heads. And it's okay, because especially in operations, context matters. And it may be that my solutions don't fit your problems at all. So I will tell you how I do it, why I do it like that, and use your best judgment to decide whether my solutions fit your problem actually. So I won't be talking about platform as a service providers, at least not explicitly. Each of them is different, and it's kind of their job to deploy applications. If you are interested in deploying on Heroku, you should have been in Kenneth Wright's tutorial like 3 days ago. So I also won't be talking about schema migrations, because it's a very complex topic. I don't even consider it a part of my talk, but every time I've tried my talk somewhere, I've been asked about schema migrations. People, that's a topic for like a 6-hour tutorial, not as a subtopic of a talk. So, what will I be talking about? I will introduce you to, in my opinion, responsible and solid development and deployment cycle. And I will point some typical and popular mistakes along the way. That's all, but it's still a lot. So, let me take a step back, introduce you to the key concept behind everything I will be saying. And that's easy does not equal simple. Easy is the opposite of difficult, which isn't exactly a bad thing. That's what we get paid for, to solve difficult problems. Simple is the opposite of complex, and complexity is one of the worst things ever in software development. So, easy is something you come up quickly, easily. You've just read the blog post or anything. It just lies near. Simple is something you have to work for, but it will serve you well on the long run. But don't take my word for it. Let's ask a witty, old, trustworthy guy. And who's more apt than Dijkstra? Simplicity is prerequisite for reliability. And everyone who has been ever phoned out of his bed at 4 a.m. on a Sunday knows that reliability is what you really want. And to make matters more severe, it can be expanded to security. It's as simple. If you want to assess the security of a system, keep it as simple as possible. So, the corollary. Put effort into making your deployments simple. Because what's easy now may cause complexity down the road, and will make very well developments impossible at some point. So, and that's the reason why this talk is also relevant for people just starting out. Because once you get successful, reality will catch up with you, and you will pay a compounded technical debt. So, let's get started. You have a great idea for a Python application. Maybe you have even a working proof of concept. How do you bring it into production? The first question arises actually before you even write a line of code. Because on what platform are you going to develop your app on? Look, we run our Python applications on Linux. But there's no way I will ever run Linux on a desktop again. I did it for a decade. I'm served. It's okay. But on the other hand, developing on anything else than your target platform will cause problems and headaches down the road. Because packages, and not only packages, actually Python itself too, behave in often prodigiously subtle different ways on different platforms. So, does it mean we can't use our favorite Windows 8 for development? No, it does not mean, because there's virtualization and there's Vagrant. I can't do Vagrant justice in this talk, but Vagrant is a tool which makes virtualization accessible to developers. And let me just point one thing out. It helps you setting up shared folders, which just means you are developing in your favorite environment, on your favorite platform, and it makes sure that your files get mirrored into the VM, where you can run your applications, your production server, your development server, your unit tests, whatever. Right? It's great. So, now, operations told you that your target platform is going to be CentOS 5 because they hate you. So, who knows which Python comes with CentOS 5? Right, 2.4. Does it mean you have to use Python 2.4? No. You're basically trading everyday productivity for like 30 minutes it takes to get a package of the latest Python. And again, don't take my word for it. Let's ask another expert, this time not so old. Who loves Kenneth Wright? Come on. And who loves requests? Everybody too, except for David Kramer maybe. So, what has he to say to some dude who was complaining that yeah, request doesn't run with Python 2.4, and I have absolutely nothing to add. And actually, there's much more than I want the latest stuff, because if you're making money with Python, and I really hope that everybody of you will or is or whatever, it becomes your key infrastructure, and it shouldn't be really dictated by a third party, or even worse, by the version of a product of a third party. So, and it works in both directions actually. So imagine you have an application which runs only with Python 2.4. What now? Are you developing only Python 2.4? Or if you want to upgrade, do you have to upgrade all your servers? No. You need something you can rely on. So it's really not that hard. And the internet is full of pre-built packages. So, since you're all here, you're obviously smart and good-looking, but your stupid pointy-haired boss doesn't get it. And because enterprise policies, right? So there are certain shortcuts, like PyRun, to get a more recent Python on your servers. But in the end, you know, you live only once, and I would take up on such stuff if I would be curing cancer or something like that, but everything else, I think there are some tech recruiters around here, so really don't settle for bullshit. So, you have your Python, you have your platform. Write your code, do write tests, ideally 100% line coverage, because you don't want that some typo brings down your whole application. But tests are worthless if they run against a different set of dependencies in your development environment than in your production environment. So, what's the easiest way to make this sure that you have the same versions? Right, just use the system packages that come with your OS. Law. Don't do it. Unless you are writing software for a distribution, which is a valid use case. Don't ever use packages from a distribution. And unless you can make sure that there will be never more than one Python application per server, don't use global packages at all. Why? System packages are spotty. So you have basically the choice between re-implementing half of PyPI, which is not pronounced PyPy, or you end up with a clusterfuck of system packages and self-installed ones. It's severely outdated. And again, it works in both directions. Sure, you don't want to work with Python, with Django 1.3 till the next LTS. But what if you have an application with this Django 1.0? Do you want to have to port all of your applications just because operations want to update the servers? You lose control over your own development cycles, about how you distribute your working power. That's a very bad thing. So, one quick word about global packages. You can get away with them. But as soon as you have more than one application on a server, you will run into problems at some point. Just imagine one app needs request 0.8, another request 1.1. They can't run on the same server without extra measures. And programming and deploying is hard enough. You don't want to have to care about this too. And fortunately, you don't have to, because we have a great solution to that. It's called virtual environments. You create it, you activate it, you install your dependencies, you test, you test, you test. At some point, you are done. You freeze your requirements, and the whole working environment is just a pip install -r away. So, one word of caution, pin them hard. Don't rely on semantic versioning. Semantic versioning is really well-intentioned, but you're basically taking the word that some stranger on the internet won't break your applications. It will bite you, believe me. It bit me, it bites everyone eventually. If you want to have up-to-date virtual environments, use pip tools from my Twitter twin, Vincent Reason, and be done with it. So, there is one objection that comes always up when I'm discouraging people of using system packages, and it's security. You want that your distribution makes sure that you don't get hacked. And at least in my context, and in my view, this argument is total BS, and it makes me mad every single time. Let me get you one thing straight. It's your job to make sure that your applications are secure, because your customers won't care at all that it's Red Hat's fault that your favorite framework wasn't patched fast enough, right? So remember Rails, right? The patches were supposed to be applied immediately. And such holes will be found in Django eventually, so there's no reason to be smug about it. So you have to take responsibility for your own servers. Nobody else will do it. Red Hat won't explain to your customers why their credit card data is on the internet. So, seeing all that, we have code that works, we know the dependencies, everything's fine. Now we have to get our app on a server somehow, right? And for reasons I'm going to state later, I want this to have as little moving parts as possible. And I think now comes the most controversial part of my talk. There seems to be the notion that the only one true way to deploy Python applications is running Git using Fabric on all the servers. And I say, nah, don't do it. One thing straight ahead, I love Fabric. Jeffrey, if you're out there or see it on YouTube, I love you for it. And I actually use it for my deployments. That's not a question, but not like that. What's wrong with it? I don't want build tools on my production servers. Because you see, every piece of software that's on your servers can and will be used against you if you get hacked against all measures. It's simple like that. And if people can start compiling, it's twice as bad. So, it's also repetitive. I don't want to compile my C extensions on every single server. I don't want to create, upgrade, whatever my virtual environments on every single server. And I don't want to download my dependencies on every single server. Right, everybody of you should have a PyPI mirror, which you probably don't. And there's this point of security, which is hopefully fixed right now. There's a problem that we have outages, and there will be outages. And put frankly, you are wasting community resources when you are deploying the same application to 5 servers and download Django 5 times. So, what I want is a blob, something I can take, and put it on a server, and it works. And I know beforehand that it works. And if there are OS-level dependencies, I want them to be specified in this blob. And turns out we have just that. It's called native packages. And what's great about them? Well, you have introspection. You can ask a server, hey, what version of my app is installed? You have configuration management integration. You can say, this server is on this version. No matter what the newest one is, keep it at this one. And they're versatile, and that's a great thing about it, because you're getting a build pipeline when you're assembling your native packages where you can do whatever you want. And while deploying your applications, you have all kinds of shell hooks like post-RM, post-install, and all this stuff, and you can use it for any magic you need. How does it work? You need a build pod of the target platform, check your application out of VCS, create a virtual environment, install the dependencies. You remember, pip install -r. You do whatever you want, and I will tell you more about that. You package the result, specify OS-level dependencies if necessary, push it to your repo, and then you can install it on as many servers as you want. And point 4 is actually really great, because you have the final application just sitting there. So you can, for example, run tests, and if the tests fail, you can just say, no package for you. If you are using stuff like Less, SAS, or CoffeeScript, sure, you can compile them on the target servers or let the user compile it in a browser, but it's actually not what you want nowadays. You want your pages to load as quick as possible. And I actually don't want to have Node.js on my production servers either for the CoffeeScript compile, I think was it. And since this is the final stage, you can also use something like YUI compressor to compress all of your static assets together. And you can gzip them, and you can collect static for Django, or build your translation catalogs, all this stuff. And as the final cherry, you can just add cache busting tags to your templates, which I just used a version of the application. Works great. So, yeah. People think packaging is hard. And I can say you, no. Jordan Sissel gave us FPM, and it was good. This, ladies and gentlemen, is a game changer. You create your directory, you put whatever you want inside of it. You point FPM at the directory, you tell FPM what you want, and there's your dep or RPM or whatever floats your boat. That. You don't want to run an own repo server, fair enough. It's not hard, but fair enough. Well, don't. You can install system packages on the command line, or just use plain tarballs. That works just as well. Actually, if you don't have root access to the servers you're deploying to, tarballs are the only way to do it. And I'm not really religious about native packages. I just find them very handy. But what I am religious about is packaging, ready to run, proven to run virtual environments on your servers. What you want to do, though, is automate. Because if it's hard or complicated to build such a package, you won't be doing it, right? And we all want to do CD. We want to be pushing cool features all the time. So I will show you how I build packages. That's all. And basically, it's way too much code because I'm lazy. The only interesting part is highlighted for you, for your convenience. That's the name of the application, which is by convention also the name of the Git repo and the name of the package and whatnot. I specify the dependencies which I need to build the package, and the run dependencies just get handed through to FPM and are saved in the native package. So when I install this package, I'll get this is Postgres libraries installed along of it. The only kicker is you're asking, hey, what's with the deployment class up there? Right. So the problem is this is highly individual, and I'm really using a lot of convention here. So I find it hard to make a really usable abstraction of this thing. But if you want to see more code, you can have a look at my blog post about native packages. And if you don't really want to do it on yourself, there's actually an open source project called Parcel, which started as they want to implement the principles I've laid down in my blog article, which is pretty much achievement unlocked. Yeah, if you want native packages but don't want to write it on your own, consider helping out. I think they've just released a new version. Obviously, there's more than one way to do it. And I tried to link a good choice of alternatives in my article, in the page I've said before. There's even a valid way to do it using Fabric and Git. That has been written by Dave Bravender as a retort to my articles. I still don't like the approach, but maybe it's better for you. Who knows? You have to check it out for yourself. So, going on, configuration. What are we going to do with that? Let's put it in the repos too, right? Don't do it. Use a configuration management system. What is it? That's a declarative way to describe services. You say, this server is a whois server. So that means I want this package whois, and I want whois.ini in etc, and please make sure that this config has permission bit 600. And the CM chooses the path to this state, or it explodes in your face, which is just as likely. There are several solutions to it. Some of them are written in Python and require you to write XML. The most common ones are currently Puppet and our very Noah's Chef. And yeah, both of them reek terribly of Ruby. And I don't mean the source code of themselves, but the DSLs. So be prepared for that. And there's a common theme along all of them, and they are not easy at all. Because you will have to plan ahead. You will have to make decisions with information which you probably don't have yet, and then it will turn out that you planned wrong, and yeah, that's how it is. So it will be some pain in the beginning. So why anyway? Well, there's first safety and security. I prefer to run my tests which contain drop tables without the production database credentials anywhere near of my source code. It's just better feeling. It's also a better feeling if you know that some piece of automated software is making sure that your SSL keys have the right permissions. Or just imagine you have a coworker who just told you that Node.js is great, so you fired him. You have to get his SSH key from all the servers before he infests them with some JavaScript, right? So you can do it by hand, but I guarantee you will forget at least one server, right? So it's better to have something automated which is intended to do just that. The main point is reproducibility, though. Imagine a backend goes down, or you get mentioned on TechCrunch. You want a new backend in, well, minutes is too long. So that's pretty easy with it. Unfortunately, most about configuration management, and that's also the reason why many people really defer using it, is that it's about delayed gratification. And delayed gratification is something humans are inherently bad at. But take my word for it, that many things down the road just aren't possible without a proper configuration management. And we had to puppetize our infrastructure after 10 years. It was a rough trip, I wish to nobody, so start early. Speaking of later, in this very room, Kate Huddleston will speak about Chef, so if you're interested in CM in general or Chef in particular, just stay seated. Now, I will help one of the main reasons for CM, and that's when you think that you are ready to bring your app into production, but actually you have to test it before it works in your production environment. But that's kind of a chicken-egg problem, right? So what do? You set up a staging environment, which basically means you build an exact replica of your production environment, but the only difference being your new app or a new version of your app. And there you go. You can test you can run your acceptance test, ideally automated ones. So this is not easy, but straightforward with CM. Without CM, it's basically impossible to make sure that your environments are identical. So now we are getting to the more practical parts. Like you have this awesome Django app, and it does some privileged stuff. So you have to run it as root, right? Let me get one thing straight. I love root. You won't see me using sudo on servers. I'm not one of those guys. But when it comes to network-facing applications, don't do it. The internet is full of people without a life or with a significant income from intruding into servers, your servers. So as soon as there's a 0 day in Django, you don't want them to own the whole server. Because to just give you an appetizer of what you can do as root, what you can do as a normal user is like sniffing your local traffic. So it's quite probable that you get hacked at some point. Be prepared for it. And this is one of the parts. So there are no excuses. If you need a privileged port, and if you're writing web applications, you probably don't need a privileged port. Drop privileges after listening to the port, or even better, use authbind for which allows non-privileged applications to listen on privileged ports. Yeah, if you need the power of root, because it's a user management application, whatever, there's a simple solution to that too. Write single-purpose workers. Write a tiny piece of code which you can audit for security and which does only one thing, like creating users, deleting users. So if someone gets access and hacks you, they can create and delete users all day, but they can't sniff your traffic. And we have, by now, a really plethora of great solutions for it, like Celery, which is right with it. So a healthy paranoia doesn't end with not running your applications as root, though. So make every app have its own user whose login shell has been false. Use IP tables to lock down everything you don't need to be facing the internet. Use file sockets. They are faster. They're more secure because you can, on intra-host communication, of course, you can. So they are faster. You can control the access to them using file permissions. And you don't have to come up with port numbers all the time. You just give them meaningful names. They're great. If you have shared databases between various applications, again, each application should have its own user with its own set of privileges. Give them just as much privileges as they need. Good databases allow you to limit the access on schema level, table level, or even column level. Make use of that. Use SSL for everything, and ideally even internally. If you can make sure that you have a really private network, you should really use SSL. And finally, use some kind of fail to ban. It's basically just a way to automatically block client IPs which are trying to brute force their way on your servers. You will really be surprised how many that are. So, going on. We have configuration, we have code, we have everything. We can bring it on a server, we SSH on a server, we start up a screen session, start the server, and we can detach and go to sleep, right? Show of hands, who has ever done that? Come on, we have friends around here, don't be shy. And as your friend, I have to tell you, Mayo, don't do it. It's stupid. You knew it's stupid, I knew it's stupid, but it was convenient, so you've done anyway. So first of all, you should use Tmux, not Screen. Secondly, even that is wrong. And I hate to say the word Tmux and wrong in one sentence, but in this case it is. So we have, again, a plethora of alternatives, because the times where you had to write system5 init scripts to get your app running are gone. We have great ways to get your applications running. So we are running Ubuntu. So we are using Upstart. It serves us mostly well. So how does it look like to start a Django application using Upstart? You tell it when to start, when to stop. We tell it we want to respawn when it crashes. You tell it the directory to run from, as which user, which command. That's all. You write it once, and it's done. No screen, please. So, going even further. At this point, you may have realized, and if not, I hate to be the bearer of the bad news, that Django's development server is not exactly web scale. Yeah, let's sing it. So, if you're writing web applications, you will need a Whiskey container. And it's well known that the only true solution to that is Apache together with ModWhiskey, right? Yet, comrades. First of all, using Apache is perfectly fine. I'm not hating on Apache, I'm not hating on ModWhiskey, and I'm most certainly not hating on Graham Dumpleton. But it should be a conscious decision for it. Because if you are using Apache, you get a fully fledged attack helicopter together with the added feature of Python hosting. And what if you don't need those rockets? What if you don't need it to crush your enemies? Maybe your app is good enough. So, you can take off those rockets. You can lean out an Apache server. But it's my personal preference, sorry, English is hard, to build things up and add features until they do what I want to do. Instead of taking something and stripping just to make it just do the work. So, I find that a combination of a lightweight container like MicroWhiskey or Unicorn together with Nginx give you a much better separation of concerns. So your app is doing its app magic, like sharing bagel recipes or whatever. It doesn't have to know about things like SSL, or that some users should go to SSL. That's the job of the web server, actually. And Nginx is really great at that. It will serve you SSL. It will forward all of your users from HTTP to HTTPS. It will serve you static data. It will set headers for you, which you should, because there are certain headers you should always set, like to avoid cross-site scripting. And there's even a Ghetto load balancer built in, which may serve you good enough until you are brave enough to venture into HA proxy. So, and this modular approach has one big benefit, because it makes it possible to test both of them independently, which is a really good thing. So, how hard it is to run a Django application using Unicorn? That's all it is. IRC is full of sad people struggling to get Apache do what they want. This is what would them get started. And it gets even easier, because you can just add Unicorn to install apps, and you can use manage.py. And Nginx is just as straightforward. No XML here. You define a backend. You define a location for your static files, which get automatically served. Done. Excuse me? Yeah. I wanted to keep it simple in that case. Yeah, that's about it. It's really, I find it more pleasant than Apache's XML, but your mileage may vary. And again, Apache is perfectly fine. And if you think that you need Apache, or if you're considering using Apache, I have another great news for you, because the one person you should listen to is Graham Dumpleton, who wrote ModWhiskey, and he will be in this room just after Kate, so this track is getting just better. So, now, acceptance has passed. We are ready to deploy. You merge your changes from your staging environment into your production environment. Done. Trigger your CM, and it might not get well. So, this is a crucial point, actually, because if you've done everything I've told you, getting from there back to here is trivial. You revert the changes in CM, which also reinstalls the old version, which you know that works, and everything's fine. And you have all the time you need to investigate problems. And did you see what happened here? The actual deployment is quite easy, and it's what you want it to be, because this is the only spot that affects your customers. So you want it to be fast, predictable, and easily reversible. And this last point is more important than you may think, because being able to quickly roll back from a failed deployment instead of fiddling on the target servers is a sign of mature deployment practices. So, your app is up. You have to make sure that it stays up. How do you make sure that it's up? You need to know when it's down. How do you know that it's down? You need monitoring. The easiest way to get into monitoring is just get pingdom. Sign up, add test, works. At some point, and it should be really soon, you realize that Pingdom won't do everything you need, because it's not enough to just monitor your front-facing page. You have to monitor everything you need to be confident in. And that's, for example, I hope you all are doing backups. Are you monitoring your backups that they work? That you can actually import them afterwards? You should. Just as the same. Remember our Node.js guy? If you to have confidence that their SSH key is removed from all the servers, you have to monitor that CM works on every server. So you will need something that runs in your internal network, the old vulnerable Nagios or the shiny fork Ichinga. We use Ichinga for internal tests plus additional tests in Pingdom, because just to make sure that our routing isn't skewed or something like that. Because it's nice when your internal monitoring realizes there's a problem, but if routing is broken, they can't send you an email, right? So, but knowing that your app is down is not enough to be a true master of your app and captain of your uptime. Yeah, this was culture. Think about it. In order to predict problems, which is much better than solving problems, you need to know what's going on right now. So, you need metrics. And again, there's a really quick and easy way to get into it. It's called Liberator Metrics. You sign up, you start posting metrics, and you get really beautiful graphs. Yeah, again, at some point you will realize, first, it gets pricey when you collect a lot of metrics, and you should collect a lot of metrics. Secondly, sending the metrics all over the internet is kind of wasteful. So you will probably end up with a combination of Graphite and StatSt, like most of us, which are both a major pain in the butt to set up. And I wish Linux would package them instead of Django, but it's just crazy me talking here. So what metrics should you collect? All of them. Server load, users online, request durations, mails in, mails out, whatever. In order to be able to make informed decisions about the future of your development, you need to know what your app is doing. And these tools are those who will tell just that. So, and as soon as you know what's going on, you can return to the fun and games part, programming. So, this marks the end of my talk. I encourage you to follow me on Twitter, read my blog, study the material I've collected for you. I put a lot of effort into it. And if you speak German, please get your domains at Vario Media. For their generosity is the only reason I'm here. Thank you.
All right, everyone. First, we wanted to thank Henrik here for everything. That was great. And we want to let everybody know there's going to be a PyLadies auction tonight. It's at 6:30 upstairs in rooms 209 and 210, and they have a whole bunch of stuff there. There's like iPods, there's some stuff signed by Guido, and all kinds of stuff. And then if anybody has any questions, we've got a microphone set up over here in the middle. You can just walk up to it and ask your questions.
Hi. How do you feel about talks for building virtual ends?
Again, please?
So talks, as in Holger's tool for automatically...
Talks. Talks is awesome. Talks has one problem right now, and that's that you can't use it inside of those awesome guest file systems I told you about. It doesn't work there because it runs setup sdist, which uses hard links, and hard links don't work on guest file systems.
That was going to be my next question. Does that actually work? No, okay.
No, I've opened a bug on Talks, and I've been asked to fix it, which I maybe at some point will do, but it doesn't work right now.
How does FPM work with C extensions and compiling against your local system versus something reproducible?
FPM hasn't to do anything with that. You build your virtual environment on a target platform. So the binaries are packaged together with it. And since it's the same platform, like your production environment, it just works.
Okay.
And it's important that you really keep the environment same. It's not okay to use a slightly older Ubuntu for a slightly newer Ubuntu that will break. I tried it, it breaks.
So how do you manage that? Just
That's not about managing. You have a build server of the target platform. That's a hard rule for that, because otherwise you will run into problems.
I think my question may be a little similar to his. We package our programs very similar to what you presented here, but we don't control our deployment environment. Our customer does.
Yeah.
So we installed, or we gave them the package, they installed it, and someone got the bright idea to run.
Can you speak a little bit louder, please?
Someone got the bright idea to run apt-get update on that machine after they installed our package.
Yeah.
And the error message that they got was basically that import sys was not available. And do you have any suggestions other than telling them don't do that?
I don't think I can answer that here in a minute, so maybe catch me later and give me more context.
Okay, thank you.
Any other questions anyone has? All right, well, everybody, let's give Hinnick another round of applause. Thank you.